Hello everyone, today in this video we are going to talk about the average value and the RMS value of an alternating current. So after this video you should be able to derive the expression for average and RMS value of AC current and calculate the average value and RMS value of AC current. Now let's understand the average value of AC current by taking an example. We know this is the graph of an alternating current, and we also know that in alternating current the charges do not move in one direction, they oscillate from their mean position. So the direction of motion is in both sides, and during first half cycle suppose the charges are moving towards the right, and in second half time period the charges are flowing towards the left. So if you consider only half time period, that time the charges move in one direction only, and if you consider a direct current, the charges flow in one direction every time. And suppose in time t by 2 the DC current sends the same amount of charge that is sent by the alternating current in half time period, that time the value of this direct current is the average value of this alternating current. So the value of direct current which sends the same amount of charge in the circuit as sent by the alternating current in its half time is called average value of that AC. Now we will derive the expression for average value. So this is the graph of AC, and you can see with the time the current increases, decreases, becomes 0 and goes to the negative side. And if you consider a time interval from here to here, you can see there is change in current. But if you consider a very small time interval, the change in current is very small. And if you take this time to be very small, that time we can say the current is almost same in between these two times. So if the time is very small, we can consider the value of AC is constant, and this is the expression for AC. And let dq be the charge that is sent through the circuit in time dt, and this time dt is very small, so that current is fixed. So we can write charge is equal to current into time. So charge is small charge dq, I into dt. So if you put the value of I from here, then you will get Im sine omega t dt. Now if you want to find the charge sent by the current between time 0 to t half, that is half of the time period, that time we have to integrate the charge from 0 to t half. So now we are integrating, and integration of dq is q, Im is constant, that is peak value, I am taking it out, and we have to integrate sine omega t dt. Now integration of sine is minus cos omega t, and this omega will come into the denominator. Now this is the final expression, and this is the limit of integration 0 to t half. Now I'll put the value of omega, that is 2 pi by t. So this is 2 pi by t, out here also I can write 2 pi by t. Now I'll put the value of limit. So in first case I'll write the upper limit instead of t, so this is cos 2 pi by t into, instead of this t I'll write t by 2, upper limit minus, and cos 2 pi by t into second limit is 0, so 0 into 2 pi by t is 0, so just I am writing cos 0. Now you can cancel this 2 and 2 and t, and you are left with Imt by 2 pi cos pi minus cos 0, and the value of cos pi is minus 1 and cos 0 is 1. Minus 1 and minus 1 will give me minus 2, and this minus will become positive 2. So this is Imt by 2 pi into 2, so this 2 and this 2 you can cancel. Now you are left with total charge is equal to Im t by pi. If IAV is the mean value of AC over a positive half cycle, then the charge flowing through the circuit will be given by this, and we know current is equal to charge by time. So now I'll put the value of charge, that is Im t by pi, and time is half time period, so I average is equal to 2 Im, that is I maximum or peak value or amplitude divided by pi, and if you put the value of 2 and pi, you will get 0.637 Im, or you can say average value is equal to 63.7% of peak value, and peak value is Im. The mean value of EC over positive half cycle is 0.637 Im, and over negative half cycle is negative 0.637 Im. And in last video we have seen that the average value of an AC over a cycle is 0, and now you can prove that from this. So the mean value of AC over a complete cycle is the value during positive half cycle plus value during negative half cycle. So if you add these two, you will get 0. Now next we will talk about the RMS value. Suppose you send AC through a conductor, the current produces heat due to heating effect of current. If you send the DC also, the heat is produced. If you send the AC and DC for the same amount of time, that is time period T, and if the heat produced by AC and DC is equal, then the value of DC is called RMS value of AC. So RMS value means root mean square value, and this is a DC current which produces the same amount of heat through a circuit as produced by the AC current which flows through that circuit in the same time T. So now let's derive the relation. So we are considering the AC current. I is equal to Im sin omega t. Im is the peak value and it is flowing through the resistance R for time dt, and this time dt is very small. Now the heat produced during the small time dt is given by H is equal to dH is equal to I square RT. This is Joule's law of heating. Now I'll put the value of I from here. So this will be Im square sin square omega t. Now to find the total heat, I have to integrate this from 0 to time period t. So now this I square m and R is constant will come out, and we have to integrate 0 to t sin square omega t dt. And in this expression we don't have the formula for integration of sin square, so I have to simplify this sin square. So formula for sin square omega t is 1 minus cos 2 omega t. So I can write this. So now next I'll open the bracket, so I'll integrate dt and cos 2 omega t dt separately. So integration of dt is t, and the limit is from 0 to capital T minus, and integration of cos is sine, and this 2 omega will come in the denominator. So in next step I am taking this 2 omega outside the bracket because it's a constant. Next I'll put the value of limits. So for this t I'll write upper limit t minus lower limit 0, and this side I'll write, instead of t this t I'll write upper limit sine 2 pi by t into t minus, I'll put 0 for this t, and if you put 0 for this t you will get sine 0. Now t minus 0 is t, and if you cancel this t you will get 4 pi. So now sine 4 pi is 0, so you are left with Im square R by 2 into t. So this is the total heat produced in the circuit, and if IRMS is the current flowing through the circuit, that time the heat produced by the AC will be H is equal to IRMS square RT. So this is Joule's law of heating, but we have derived H is equal to Im square R by 2 into T. So I can equate this to H now. Now you can cancel this RT and this RT, and IRMS square is equal to Im square by 2. So next step, you take this square this side and it will become root over, and root over of Im square is Im, and root over of 2 is root over 2. If you put the value of root 2, that is 1.414, you will get IRMS is equal to 0.707 Im. So RMS value is equal to 0.707 of peak value. So, or we can say IRMS is equal to 70.7% of Im. So RMS value of alternating current is 70.7% of its peak value. And AC voltmeter and ammeter measures RMS value of voltage and current. If I say the AC current is 5 amperes, that means I am telling the RMS value. So RMS value of that current is 5 ampere. So in our previous video we have discussed that AC is more dangerous than DC. Suppose we are taking the AC voltage of 220 volt, that time I am telling its RMS value. So if you find the peak value or the highest voltage that you can get from that AC voltage is 220 into root 2. From this formula I'll get 310 volt. So we are getting more voltage than 220 volt. So AC is more dangerous because from 220 volt AC I am getting 310 volt peak value. And these are the formulas. This is for RMS value and this is for the average value. And if you consider the voltage, you have to just change I with V. So let's solve one question. The peak value of an AC supply is 300 volt. What is its RMS value? The RMS value of current in AC circuit is 10 ampere. What is its peak value? So first question, peak value is given Vm, so I can find Vrms, and current, and for current RMS value is given, so I can write IRMS is equal to 10 ampere, and we have to find the peak value. So peak value is root 2 into IRMS, so you can easily find this. Next question, the peak value of alternating voltage applied to 50 ohm resistor is 10 volt. Find the RMS current if the voltage frequency is 100 Hz. Write the equation for instantaneous current. So out here resistance is given, peak voltage is given, frequency is given. So using this I can find the current using Ohm's law. Now after finding the mean current, you have to find the RMS current, and RMS current is 0.707 into Im. And next you have to write the equation of instantaneous current. Now this is the equation of AC current, so you have to put the values. Im you have already got, and omega is 2 pi into frequency, and frequency also we have, so you can put the value of Im and omega and you can find the equation. So in this question the equation of AC voltage is given by E is equal to 140 sine 300t, and t is in seconds, and we have to find the peak value of the voltage and RMS value and the frequency. So I'll compare this equation with the general equation of AC voltage, that is E is equal to Em sine omega t. So we can either use V or E, it's up to you. So by comparing these two equations you will find Em to be 140, and using Em you can find ERMS easily. And again by comparing these two equations you can write omega is equal to 300, and omega is equal to 2 pi into frequency, and frequency is omega by 2 pi. So now you can find the frequency also. So this is the end of the video. Please don't forget to like the video and subscribe the channel. Thank you.